So, example 3, we're going to be simplifying each expression. In this case here, this is just subtraction. The next one's just going to be addition. One thing that I like to do when I'm adding or subtracting polynomials together is I like to get rid of the parentheses. And you just have to watch out to make sure whether you're adding or subtracting the two polynomials together. If I'm subtracting, I just write the first few terms down, but then I distribute that negative through. I change the sign of everything in that second associated polynomial there. So it becomes negative 2x squared minus 3x plus 1. Now what I go through and do is say, where are all my x squareds at? I got 4x squared here and negative 2x squareds here. That's a total of 2x squareds. Next up, I've got a negative 5x and a negative 3x. Add those together. That'd be a total of negative 8x. And lastly, the two constants 6 and 1 add together to be 7. And when I've done that, I can check. You're doing two things when you check to make sure it's simplified. You want the highest exponent in the front, and then you want it to go down in order. 7, 6, 5, 4, 3, 2, 1, or whatever the top one happens to be. You bring it down in order. Make sure you're keeping track of the coefficients. It's best to not have fractional coefficients if you can avoid it, but sometimes you can't. That's okay. But really, if you can get it all to be nice whole numbers, it would be great. And of course, it ends with the constant. And it's okay to skip. Like if I just went from x to the 7th plus x to the 3rd plus 1, that's still a polynomial, even though I'm skipping all of those degrees in between. You just have to imagine they're getting multiplied by 0. But you want them in descending order. For addition, I work it very similar to the last one, except now I don't have to distribute anything through. So I just write 6x squared minus 7x plus 8 minus 4x squared plus 9x minus 5. So you can see this time I didn't have to distribute that. Well, I did distribute a positive 1 through, which is you multiply by 1, it stays the same. But now I can do the same thing where I organized, here's all the x squareds. So that is still 2x squared. Find all of my x terms. Looks like we got a total of 2 x's. Negative 7 plus 9 is 2. And constant terms. 8 minus 5 is 3. There we go. Let's just go ahead and do example 4 right now. Simplify using the distributive property. So the idea is we have this term outside, and it's going to get multiplied by every single piece inside. So here it's going to get multiplied by 3 different things. Now I'm going to write it out fully. 3x times 2x squared plus 3x times negative 4x plus 3x times 6. Usually this part you just read out loud as you're doing it. So I'd read, 3x times 2x, 3 times 2 is 6. X times x squared is x cubed. So I just basically, while I'm doing one of these problems, I just verbalize that part of the distribution. And then I move to my next term. 3x times negative 4x. 3 times negative 4 is negative 12. X times x is x squared. All right? And 3x times 6, well, I just have to do the 3 times 6, that's 18. And the x hangs around. And there we go. There is the distribution. Now, of course, you're going to want to be careful. Let's say you had x plus 1 times x squared plus 2x plus 3. Both parts of this binomial in the front will have to get multiplied by the whole trinomial that follows, right? So just like we were doing before with distribution, where with the quadratic we had the first part times the whole polynomial, second part times the whole polynomial. Same thing here, except now there's three things to multiply by, like we just did.